Consider the velocity function for an object moving along a line. So here's a figure that describes sort of the velocity. It says, describe the motion of the object over the interval from 0 to 6. So this velocity is always positive. It's always above the x-axis. So this guy is always moving forward. And what happens is from 0 to 1 he slows down because the velocity goes down. And then from 1 to 3 he's traveling at the same speed. And that speed is like 10 meters per second. And then from 3 to 4 he speeds back up. And then from 4 to 6 he travels at another speed, a constant speed though, of 30 meters per second. Okay, it says use geometry to find the displacement of the object between t equals 0 and t equals 3. So the displacement of the object is sort of the distance that it travels. And to find the distance that it travels, I need to find the area underneath. So I'm trying to find that area. So I'm going to break it up into blocks. So what I see is I have this rectangle here, and it is 3 wide and 10 high, plus I have this little triangle up here, which is 1 wide, 10 high, but the area of a triangle is 1/2. So in total, I get 30 plus 5, or 35 meters. So that's from 0 to 3. The next part says use geometry to find the displacement of the object between 3 and 5. So here's from 3 to 5. Again, displacement is the area underneath that curve. So I'm going to break it up again, and I'm going to say, I'm going to break it up into this here, and then this one up here, and then that triangle right there. So let me color them in 3 different colors. So I have that yellow one, I have the green one, and I have that orange triangle. So the yellow one is 2 wide and 10 high, plus the green one is 1 wide and 20 high, plus the red one is a triangle, so I'm going to use 1/2. He's 1 wide and 20 high. So if I add all of those up, I get 20 plus 20 is 40, plus 10 is 50 meters. Okay, it says, assuming the velocity remains 30 meters per second for t greater than 4, find the function that gives the displacement between t equals 0 and any time after 4. Okay, so here's what we know. We found in part B that this displacement was 35. Then we found in part C all the way to here at 5 was 50, but I only want to go to 4. So I'm going to find out this amount until 4. And if you think about this amount, this one is 10, this square here is 10, and then this triangle there was 10. We found that already, so that's 20. So from 0 to 4, the displacement is 20. No, 20 plus 35. 55. Okay, after 4, it's going to be always 30 meters per second. So what I'm going to do is I'm going to take the time, I'm going to subtract off the 4 seconds I already did, and multiply it by 30, because it says it's going 30 meters per second. Plus, I have to add in this 55 meters that it already went. So the displacement, let's call it d, is going to be 30 times t minus 4 plus 55 after t is greater than or 4. So bigger than 4, this is how much it'll be displacement. You could test this by plugging in 5 to this formula, and you should end up with 50 like we did there.